So we'll begin with the givens. Q is the midpoint of PR. And we can still label what we have. We're also told that TR and TP are equal. So if we label these, so here's TR and here's TP, and then we're told that Q is this midpoint. So we can interpret that information and with the markings. In the previous proofs that we've done, I've suggested that you begin by trying to introduce the elements from the end state. In this case, your end state is a congruent statement. In order for you to finish a proof with a congruent statement, you need to have one of the patterns fulfilled. And the patterns, again, SSS, SAS, ASA, AAS. So you have one of those four choices that you need to look for. So we don't need to introduce elements from the end state, but what we do need to do is figure out what elements will give us one of those four congruence patterns. Okay, well, let's take a look and interpret what we have first. So we have TR and TP. Notice I'm writing an S along the side here. This indicates that this set of given information is one of those corresponding pieces of congruent elements. And we have two sides, a pair of sides that are congruent to each other. Okay, well, from the given statement that Q is a midpoint of PR, and I've already labeled it, what other statement can I make regarding the congruence of elements? If Q is the midpoint, then PQ and QR have to be equal. And what justifies that statement? What term did I base it on? We were told that it is a midpoint, so definition of midpoint would justify this statement. And so my markings are already there. What I'm going to do again out here on the side is I'm just going to label this element as an angle or a side. Okay. So now I have two of the three elements I need. Okay. Given two sides, I either need the other side. Is it possible for me to find the other side of this pair of triangles? Is it true that QT is congruent to QT? Yeah, so I can do that. So my third step, or a possible third step, would be to just say QT is equal to itself. And the justification for this is one of those axioms that I mentioned we wouldn't use until later, but this is the time. When something is equal to itself, does anybody recall what that was called? Patrick? Good. So this is an example of reflexive property. It also now gives us our third pair of elements that are congruent. So do we have enough now to state congruence of triangles here? Yeah. If we look at this pattern, we have these pieces that are congruent to each other. Therefore, we can make our final statement that these two triangles are congruent. And the justification is the pattern. Now, your pattern's not always going to go vertically down the side of your proof. In this case, they're all S's, so it works. SSS is your justification. But it's not always going to be that way. And let me show you an example when it's not. There's an alternative to step 3. And that is, if you either chose not to use that, or either one of these, or actually in this case, this is if you chose not to use this justification, is there a way that we could justify the angle 5 based solely on what's here now, assuming that QT step is not a part of that proof? Is there something that we can justify the statement angle 5 and angle 6 are equal? What do we know about angles 5 and angle 6? If we look at the whole triangle PTR, so looking at this whole triangle, angles 5 and 6 are related how? They're equal because they are angles opposite equal sides of a triangle are equal. Okay, so this is one of the relationships that we discussed in class. And the angles that are opposite equal sides, it's basically the base angles of an isosceles triangle are equal. So you could have determined that angles 5 and 6 were equal. If that was the case, then this would be a set of angles that we have congruent. So we'd have two sides and an angle. Is the angle included between the two sides? Yeah, so that fits one of our patterns. So we could have also made this same statement, PQT is congruent to RQT. But if we had done it in this method or this pattern in green, our justification wouldn't have been SSS. It would have been two sides and the included angle SAS. Okay. So again, you can do this in different order. You can do it with different justifications. Whatever you see will work fine. And now let's say in this problem, instead of asking to prove this, what if I had asked to prove that measure of angle 1 is equal to measure of angle 2? Okay, one of the additional things that you're going to work with beyond congruence of triangles is once you identify the congruence of triangles, what do you know about all corresponding parts of those triangles? All corresponding parts are equal. Okay, and so we've already discussed that as part of what this congruent statement reflects, is that angle P and R are equal, Q and R, or Q and Q are equal, T and T are equal. And so all of these angles are equal, so we can make the statement that measure of angle 5, which is angle P here, is equal to the measure of angle 6, which is angle R. And the reason for that is we have this congruent statement, so we can either call it definition of congruence, okay, or there's another way to identify this, and that way is the acronym CPCTC. What CPCTC stands for is, again, pretty much defining what congruence is, but it says corresponding parts of congruent triangles are congruent. Okay, C, P, C, T, C. Okay, so you're very likely going to see that. These are interchangeable for what we'll be doing. The definition of congruence will work, but usually I believe when I put it in a proof that you have to choose from a drop-down, it'll be written as CPCTC.